Okay, so section I goes over solve by using the quadratic formula. Okay, so let's just write down quickly the quadratic formula. So that is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, this should be a review from Algebra 1. The only big difference between Algebra 1 and Algebra 2 is now that you guys know what imaginary and complex numbers are, expect to start seeing them as solutions, okay? So back in Algebra 1, you only knew about real numbers. If you had a negative in the square roots, you would say no real solutions, but now you know what imaginary and complex solutions are, okay? So just keep that in mind. You might have to take out an I if you see a negative in your square roots, okay? Because section I is all about can you simplify after putting it into the quadratic formula, okay? Another thing I want to go over is when you guys are plugging in your A, B, and C values into the quadratic formula, you need to put parentheses around the values that you plug in, okay? What I mean is, so let's say you see, not negative 16, that's a really big number. You see negative 4 squared, and then you see negative 4 squared. Now, the way you say it sounds the same, but these two results in two different answers, okay? So the first one is actually negative 16, and the second one is positive 16. Now, this is an algebra trap, and that's why I encourage you guys to please, please, please put parentheses when you are plugging in your A, B, and C values into a formula, okay? In this case, a quadratic formula. The reason being is in the top problem, negative 4 squared, that is just negative times 4 times 4, okay? 4 times 4 is 16. Multiply that by negative. That's why we got the negative 16. On the other hand, when we put parentheses, this squared applies to both the 4 and the negative, okay? So the second problem is just negative 4 times negative 4. And because we have two negatives, they cancel each other out to make a positive, and 4 times 4 is 16, okay? So again, please do not fall for an algebra trap by just putting parentheses around your A, B, and C values, okay? So let's just go ahead and delete that and go into question number 5, okay? So question number 5 is a non-starter. We cannot do anything until we have it in standard form. The standard form of a quadratic formula, of a quadratic function requires us to set it equal to 0, okay? So we're gonna move this 7b over to the left side, okay? So we're gonna subtract 7b. So we have negative 3b squared minus 8b plus 5 equals 0. Okay, so now that it's equal to 0, I can go ahead and start identifying my A, B, and C value. I know some of you guys would prefer to just put A, B, and C, but please do not do that. You're going to need to write down A equals this, B equals that, and C equals something. The reason why I recommend you actually writing down A, B, and C is equal to this is what most people would do is, for example, if I just put B right here, I might just accidentally see that as it's an 8, but B is not 8. So please write down A equals, B equals, and C equals. So I can identify my A value is negative 3, my B value is negative 8, and my C value is going to be 5, okay? So now I'm just going to go ahead and plug that into the quadratic formula. So that's going to be opposite of B, and remember to put down parentheses when you're plugging in your A, B, and C values, okay? So opposite of b plus or minus the square root of b squared minus 4a, so a was negative 3, c, all over 2a. Okay, so now here comes the hard part when it comes to the quadratic formula. You need to be able to start simplifying, okay? So these two negatives right here become positive, so I have positive 8 plus or minus the square root of, well, negative 8 times negative 8 is 64. And then negative 4 times negative 3 gives me positive 12. Positive 12 times 5 is, I believe, 60. Yes, it's 60. All over 2a, so that's negative 6. Okay, so I'm going to continue on in the next line. So I have 8 plus or minus the square root of, let's see, 100 and, let's see, 64 plus 60 is 124, I believe. So 124 all over negative 6. Okay. So what we have to do next is simplify if we can. Now, inside the radical is 124. Okay. If your inside of the radical is not a prime number, that should be a clear indicator that maybe you could simplify the radical. So let's go ahead and see if we can take out something from the square root of 124. So that's going to be 2 times 62 because we have an even number. And 62 is another even number, so 2 times 31. Oh, look, I can take out a 2. Okay, and then 31, I believe, is a prime number. So we're just going to go ahead and take out that 2. So we have 8 plus or minus 2 radical 31 all over negative 6. Okay, so at this point, you should notice that 8, 2, and negative 6, they're all even numbers. That means we can further simplify this. Okay, so I'm just going to take half of 8, half of 2 is just 1, so you can just choose to just leave it as 1 right here. Or you can also just not put the 1. It's a given that there is a 1 in front of it. All over negative 3, okay? So this is as far as it goes when it comes to simplifying. We're going to go ahead and box our final answer. The reason why we know this is as far as it goes is because inside the radical is a prime number, and 4, 1, and negative 3, they're not all even numbers, so we are good. This is my final answer. Okay, so let's move on to question number 6. So we're doing the same thing, solve by using the quadratic formula, okay? For question number 6, it's not in standard form, which again is the ax squared plus bx plus c is equal to 0. Okay, so all I'm going to do is just add 4n to both sides, 4n squared to both sides, and then subtract 9n. So subtract 9n. Okay, so we are going to be left with negative 5n squared. Let's see, negative 5n squared minus 9n minus 9 is equal to 0. Okay, so now that it's in that variable squared, and then we have the x, and then we have the number, which is just the standard form, we can go ahead and identify our a, b, and c. So a equals negative 5, b equals negative 9, and c equals negative 9 as well. So I'm just going to go ahead and plug this in. So we have opposite of b, which is negative 9, plus or minus the square root of let's see, negative 9 times negative 9 is 81, okay? Minus 4, A is negative 5, C is negative 9, all over 2A, okay? And then now we're just simplifying this. So 9 plus or minus square root of 81. Negative 4 times negative 5 is, I believe, positive 20, and then 20 times negative 9 is minus 180. Okay, all over 2A, which is negative 10. So continue simplifying. So 9 plus or minus the square root of 81 minus 180. Let's see, that will give us negative 99 all over negative 10. Now, we have a problem, and that problem is that negative in the radical. As soon as you see that, your next step should be take it out. Okay, so 9 plus or minus, we got the I. And on this side, I'm going to just also see if 99 can be factored out. So square root 99, that is, let's see, it's not an even number, so it's not divisible by 2. So we go on to the next number. The next number is 3. Well, 3, so a number is divisible by 3 if the sum of the digits is divisible by 3. So 9 plus 9 is 18. 18 is divisible by 3. So we can take out a 3. And so 99 divided by 3 is 33. Notice 3 plus 3 is 6. 6 is divisible by 3. So we can take out another 3 and we get 11. Okay. So outside the radical, we can take out a 3. And inside my radical, I still have that 11. So put the 3 in front of the I. And then after the I, we're going to put radical 11 all over negative 10. Okay. So let's just go ahead and double check. 9, 3, and negative 10. They don't have a greatest common factor. They're not even. And so we cannot simplify this any further. Inside my radical is a prime number, so I am good. And I have that I because of that negative in the radical. Okay. So let's go ahead and box to our final answer. Okay, so the most important part of section I is you guys need to know your quadratic formula, okay? And you cannot start to identify A, B, and C unless it is in standard form and is equal to 0, okay? And please use parentheses. You may have noticed I've been using parentheses throughout question 5 and 6. They will help you avoid any algebra traps when it comes to the quadratic formula, okay? So that is section I.